The purpose of this video is to review concepts that you've learned in Algebra 1, more specifically the properties of exponents. We're going to start off with the product rule that says when you multiply two terms that have the same base, you can add the exponents. But again, they have to have the same base. So here, they both have a base of x, meaning I can combine them by adding the exponents. So this is x to the 3 plus 8 power. 3 plus 8 gives me x to the 11th power. Now, because this is a variable, we can't simplify any further, but if we have something like b where we have numbers as a base, you'd want to simplify your answer all the way. For example, because they have the same base and I'm multiplying, I can add the exponents. So 2 and 4 added together would be 6. 2 to the 6th power can be evaluated. You can plug that into your calculator and you would get 64. I'm going to show you how to plug it into a TI-30X. All you have to do to plug in something to a power is you type the base first. So in this case, I have a base of 2. And then to get a power, I would use this little caret button right here. And then it was to the 6th power. For part C, I want you to notice that we have two different variables. Now we are multiplying because when I have parentheses times a parentheses, I do know it's multiplication. You can only combine the ones with the same bases. So here I have an x squared and an x cubed, which give me x to the 5th power. And then we have a y to the understood 1st power and y to the 4th power. So 1 plus 4 is 5, meaning I have y to the 5th power. Okay, next we have the quotient rule. When we multiply, we add the exponents. When we divide, we would subtract the exponents. So for part A, we can see we have the same base, once again, x and x. So all I have to do is you do 5 minus 2, the power that's in the numerator, and then you subtract the power that's in the denominator. So it's x to the 5 minus 2 power, or that's x cubed. Part B, we have 3 to the 5th power over 3 cubed. Because they have the same base, I can rewrite this as 3 to the 5 minus 3, or 3 squared. And since that is a number, we can go ahead and simplify this. We know that 3 squared is 9. For part C, once again, we have a multivariable expression. So you can only combine stuff that has the same base. Here I have x squared over x to the understood 1st power. So it's x to the 2 minus 1, or 1. And then we have y to the 5 minus 3, or y squared. I didn't have to put that 1 there. Whenever we don't put an exponent, it's understood to be 1. Let's take a look at the next rule. So this is called the zero exponent rule. It's saying that regardless of whatever base you have, if you have something raised to the 0 power, it's always going to equal 1. So y to the 0 would be 1. 6 to the 0 would be 1. This whole thing raised to the 0 power is 1. A common mistake that I see here a lot is people try to distribute the power of 0. We cannot distribute when you have addition or subtraction. I want you to write this down because, again, it's a very common mistake. You cannot distribute when you add or subtract inside of the parentheses. The only time you can distribute a power is if you have multiplication or division, and we're going to see that later on in the notes. All right, moving on to the next rule. So we have the power to a power rule. When we have a power to a power, so two exponents right next to one another, we would multiply them together. So for part A, we have x cubed being squared. 3 times 2 is x to the 6th power. Next, for part B, we have 3 squared being raised to the 4th power. So we would go ahead and multiply 2 by 4 to give us 3 to the 8th power. It's okay if you don't know what 3 to the 8th power is right off the bat. Remember, you are capable of plugging it into your calculator. So 3 to the power, hit that little caret button, then 8. I get 6,561. And lastly, for part C, we have z to the 5th power being squared. So really I have z to the 5 times 2 or z to the 10th power. All right, next, we're going to see what it looks like if we were to expand a power rule. For example, this is what I was talking about earlier. When I'm multiplying two different bases together and it's being raised to the power, this is when you can distribute that power. So when you multiply, you can distribute. When you divide, you can distribute as well. So I'm just going to make a little note. When you multiply or divide, you can distribute. But remember, if we have something like what we had over here, right here for part C, whenever we add or subtract inside of the parentheses, you cannot distribute. It's a very important distinction to make. All right, let's start with A. I have two different bases, a 2 and an A. Both of these are understood to be raised to the 1st power since there's no other exponent listed. So I can go ahead and distribute that 3 to each of the terms. When we have a power to a power, we multiply the exponents. Remember, a power to a power, we multiply. So I have 1 times 3 and 1 times 3, giving me 2 cubed and a cubed. You always want to simplify your answer if you can. So we can simplify terms that have a number as the base being raised to a power. So 2 cubed, remember 2 cubed is not 2 times 3. 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. And then a cubed remains unchanged. Let's take a look at part B. So for part B, I have two different bases. I have 6 to the 1st power, and I have x cubed. This whole expression is being squared. So I can go ahead and distribute the 2 because I'm multiplying. And power to a power means that I multiply those as well. So I have 6 to the 1 times 2, or the 2nd power. And then I have x to the 3 times 2, which would be to the 6th power. I can simplify this further. I know that 6 squared is 36. So this is a 36x to the 6th power. All right, part C. Remember, we can distribute the power when we multiply or divide. So here I have division. Notice how there's a lot more than just two bases. I have a 2x, 3, and y. So when I go ahead and distribute this power of 3, it needs to go to everything in the numerator and everything in the denominator. So really, the whole expression 2x is being cubed, and the whole expression 3y squared is being cubed, which would make it look like A and B, where I have to distribute that 3 to each of the terms that I'm multiplying. So this is 2 cubed x cubed over 3 cubed y to the 2 times 3, which is 6th power. If you can, you'd like to simplify further. So 2 cubed, remember, is 2 times 2 times 2, which would be 8. And then x cubed. 3 squared is 3 times 3 times 3. So 3 times 3 is 9 times 3. That would be 27. Y to the 6th power.